Welcome to our last, for now, ramble on IEB's paper 1 of November 2023. We are looking at the finale of that paper, question 12. I think it was the last question. Question 12, yeah. So, below is the front view of a rectangular storage facility built onto a wall represented by MO in the diagram below. Okay. The roof is attached to the wall at M with MO equals 6 meters. Okay, so they've ever so kindly given us a Cartesian plane to work with, so we will work with it. So M is at 0, 6. The gradient of the roof MN to NP, okay, must have a ratio of 2 to 5. Okay, so the rise and the run is 2 to 5, so pretty much the gradient of MP is negative 2 over 5. Okay. PR is a vertical beam, okay, so whatever the x-coordinate of R is, that's the x-coordinate of P. NP is a horizontal beam, so yeah, the y-coordinates of N and P are the same. So these are 90s. Okay, and then OR represents the ground. Cool. So, yeah, okay. Righty doos. First question says, determine the equation of the line MP that represents the roof. Okay, so that's nice and easy, right? That is the gradient we've been given and the y-intercept we've been given. Let's see if there was anything more to that in the memo. No, yeah, straightforward, just from the data we've been given. Okay, the next question says, below is the rectangular storage facility under the roof MP shown in 3-dimensional form. Okay, so it's almost like it's doing that, right? That's the picture that they've shown us over there. Okay, right. If the depth of the rectangular storage facility, okay, we also just need to hold on to that other information we were given. Okay, so if the depth of the rectangular storage facility is 2 meters shorter than the width, okay, so if this is W and then this is W minus 2, okay, then determine the length of the vertical beam, this guy, so that the rectangular storage facility will have a maximum volume when placed under the roof MP. Yeah. The roof must remain fixed at M and the ratio of Mn to NP must remain 2 to 5. Okay, so it's a situation where we might decide that we want the width to move in a little bit, okay? So this is fixed. That roof line is fixed. So we might want to move our W in a little bit. The depth will be W minus 2. Let's not really think about that right now on a 2D Cartesian plane, right? So then that would mean the vertical beam needs to become a bit taller, right, in order for it to meet the roof. So the roof is not changing. The equation of the roof is not changing, right? All that is changing is W and the resulting height of the beam. We can call that H. Okay, right. So I am going to say, let the width be W and the height of the vertical beam be h. Okay, so then the volume of the warehouse will be given by, well, first of all, so therefore the depth will be given by W minus 2, okay, right? And therefore the volume will be given by W times W minus 2 times H. Okay, but another interesting thing is that that vertical beam is always going to meet the this roof line, right? So it is going to be a point that lies on that line. So because because we know that this is a vertical beam, we know that the x coordinate of r is the same as the x coordinate of p, and because the x coordinate of r is w, whatever the width we've chosen is, that means the x coordinate of p is also going to be w, right? So the x coordinate of the point P is equal to the x coordinate of R, which is whatever w we choose. So that means the y coordinate of P is going to be negative 2/5 times w plus 6, right? The equation of that roof line. Okay, so negative 2/5 w plus 6. So in fact, we can revise our little formula here. Okay, to say, therefore, vertical beam height, okay, because we're only looking at the volume of the, okay, no, I'm thinking about something else. I'll get to that. The vertical beam height is going to be negative 2/5 of w plus 6. Okay, and I was just saying that, okay, we're not looking at the volume including the space that the roof takes up. We are only looking at the volume of the rectangular storage facility, maximizing that. So, okay, the volume of the rectangular storage facility will be the width times the height times the depth, which is 2 less than whatever w is. Okay, so let's just times that out quickly. So here we have negative 2/5 w squared plus 4/5 w plus 6w minus 12, which is w times negative 2/5 w squared plus, that'll be 34 over 5 w minus 12. Okay, and if we times that out, we get negative 2/5 w cubed plus 34 over 5 w squared minus 12 w. So that is the volume in terms of whatever width we choose, and we want to see when we're going to have a maximum volume. So this is okay, I'll just draw in the rest of the Cartesian plane. Okay, so this is the graph of v against w, okay, and it's going to be this is a cubic function where the coefficient of the cubic term is negative, so we have something that does that. Okay, so potentially, I don't know, something that does that, right? And we only care about this part of the graph, right? The parts of the graph where v is positive, because for our context, v cannot be a negative number. And more specifically, we care about where that local maximum is occurring. Okay, v can't be a negative number because a volume can't be negative. Okay, so we want to find the maximum turning point for this function. And how do we do that? Of course, we do that using derivatives. Okay, so we're going to find the first derivative of v. Okay, so that is going to be negative 3 times 2/5, which is 6/5, w squared, and then 2 times 34/5, which is 68/5, w, and then the last term just becomes negative 12. And we want to see where is this equal to 0. So we are solving this quadratic equation. The crazy part of me, just slightly crazy, wants to try and solve this without a calculator. Let's see how far we go. So I'm going to times both sides by negative 5. Okay, so times the whole equation by negative 5. So then we end up with 6w squared minus 68w plus 60. And this just becomes 0. Then we can divide right through by 2 is the highest number we can use. Ooh, I don't think it's gonna work, but let's see. Plus 30 is equal to 0. Okay, so my method of factorizing, I use grouping. So I'm looking for two numbers a and b such that a times b is equal to 3 times 30, and which is 90, and a plus b is equal to negative 34. So that means I'm going to look at the negative factors of 90 and see if any of them add up to negative 34. So 90, we could have minus 1, minus 90, minus 2, minus 45, minus 3, minus 30. That's quite close. Minus 3 minus 30 would give me minus 33. Minus 4, no, 4 does not go in there. Minus 5, minus 18. Adding those together would give me minus 23. So now we're moving away from, now it's just going to get smaller and smaller. Minus 6 minus 15 is minus 21. No, this is not going to work. We're now going to minus 19. Okay, no. So this doesn't look like it can be factorized. Again, I've said this in another video, when things like this happen in the context of an exam, I just start feeling like, oh no, did I get something wrong somewhere? So I am, because in another video I had the same hunch and I decided to carry on anyway, and then I did in fact get it wrong. So I am going to just double check my numbers real quick just to be safe. Okay, we already know that we got the equation of the roof right. We know that the depth is going to be 2 meters shorter than the width, so that is w minus 2. Then we said the x-coordinate of p is going to be the same as the x-coordinate of r, which is w. So then the y-coordinate will be negative 2/5 of w plus 6. Okay, and then now to get the volume, we said w times that, yes. So this is negative 2/5 w squared, positive 4/5 w plus 6w minus 12. Okay, I stand by that. Then this and this together, this is the same as 30/5. So if I add them together, I end up with 34/5. Yes. Guys, the battery mustn't run out on me. Then we end up with negative 2/5 w to the 3, 34/5 w squared minus 12w. Yeah, I agree with that. Then the first derivative will be negative 6 over 5w squared. This one will become 68 over 5w, and this one will just be minus 12. And then looking for where this will be equal to 0, I times throughout by negative 5. So then I ended up with positive 6, negative 68, and positive 60. Yes. And then divide by 2, 3, minus 34, 30. Yeah, okay. So I'm going to take it to the quadratic formula. So W is equal to minus 34 plus or minus minus 34 squared minus 4 times 3 times 30 divided by 2 times 3. And I'm just going to chuck it into the calculator as is. Your calculator is still figuring its life out. We are running out of battery. Calculator, do you not see the urgency of this matter? So this is 34. Let's start with the plus. 34 squared minus 4 times 3 times 30. Oh my goodness. And then I didn't square root. Oh, Jehovah. It's like I'm the only one that's serious about what's happening here. I'm the only one that cares. Okay, so 34 plus the square root of, so this is 34 squared minus 4 times 3 times 30, and then 2 times 3 at the bottom. Okay. So we end up with W is equal to root 199 plus 17 over 3, or with the minus, it becomes negative 2 root 199. Okay, let's move this here. W is equal to negative 2 root 199 plus 34 over 6. Again, we saw that both of those are positive numbers. And I cleared them. Right, so root 199 plus 17. Oh dear. Okay, I'm starting to get agitated. So I'm starting to type funny. Root 199 plus 17. Okay, divided by 3. Okay, I'm actually just going to store that. So that is equal to 10,36 blah blah blah. And the other one, I'm going to store that one as well. Negative 2 times root 199. Oh no! Negative 2 times root 199 plus 34 divided by 6 is 0,964 something, right? So let's just store that one as well. Okay, so we already kind of know from our intuition of the graph that the bigger one must be the maximum. But to prove it formally, we can use the second derivative of v, right, to check, concave down. So let's get the second derivative of v quickly. So let's just get a picture of that first. Hello. And let's check it down here as our point of reference. Let's move this one over here. And let's move all of them up. Okay, so the second derivative is negative 12 over 5w plus 68 over 5. Okay, so let's look at what is the value of v double prime for this first guy. So that'll be negative 12 over 5, not over 2, times that first value, I think, plus 68 over 5. Okay, what does that give us? So that gives us negative 11,28 something something something. Negative number, which means at this point the graph is concave down. Okay, right, which we already again intuitively knew, but let's just double check that the other point does give us a concave up result. Okay, so now here we're going to put in B. Right, so now we get 11,28 which is a positive number, which means at this point the graph is concave up. Okay, so this tells us that when W is equal to, what was that number? Let's just write it out in third form. Root 199 plus 17 over 3. Okay. V is at its largest. Okay, so let's go back to what the question asked us for, the final result. We need to determine the length of the vertical beam. Okay, and remember the vertical beam, the expression for that height is this. Okay, so let's just take this over, copy to where we found the W that maximizes the volume. Oh, okay, right, paste. Okay, so beam height, okay, will be equal to, and let's, oh, did I say paste image? Yo, okay, let's try that again. Paste, just paste the thing so that I am able to move it apart. Awesome. So now we're gonna sub in our root 199 plus 17 divided by 3. Okay, and let's see what we get. Okay, so we end up with 1,8 meters as our final answer, which is not very high. That's as tall as my dad. I'm a bit nervous. They get 1,9. Oh yeah, it is 1,9, sorry. Rounded off, it becomes 1,9. Let's just see that we did get the same values for x. We got 10,3 something something something. Okay, fantastic. So what a nice optimizing question to wrap up the paper. See you for the start of another paper in another video. And of course, if there's a different question that you would like to see covered, you can hit me up in the comments, or if you want a certain question redone, because I do ramble a lot, but after like 1 or 2 rambles, I do start to like become a bit more succinct and clear. So if you want me to do another take on a question, you can also let me know in the comments and I'll happily do that. Peace and love.